So the notes we're doing today are in continuation from yesterday, where we were doing the converse, where we're trying to prove that two lines are parallel by knowing that angles are parallel. So we look at this first proof that we need to do, and I walked around the room and all of you were like, oh yeah, I know how to start this. You know what though? Day one, did you know what to put here first? You did not. So you have learned something. We put what is given to us as our statement one, and our reason one would be given. Now, usually I would go over and mark these congruent, but the book has already done that, so. Okay, now our goal is to prove that G is parallel to H. Okay? Wait. Yes. Nope, I lied. Our goal is to prove that G is parallel to H, but we want to do it to show that alternate interior angles converse. So 4 is congruent to 5 is given. Our step 2, that can't be right. Alternate. Oh, this would be if we knew the. Okay, so sometimes I hate proofs just because of this. It gets confusing. This is knowing the corresponding angles converse. Oops, converse. This is if we know the corresponding angles converse theorem. How could we prove the alternate interior angles converse theorem? Okay, because right now, if I just say that this is congruent to this, then I've already used that theorem that we're trying to prove. So we can't use the theorem that we're trying to prove. Does that make sense? We can't use the theorem that we're trying to prove. But we do know the corresponding angles converse theorem. So what I'm going to do is I'm going to show that angle 1 is congruent to angle 5. If I can show that angle 1 is congruent to angle 5, then I know these lines are parallel, which will mean that 4 and 5 are also congruent, and we could have used those in the first place to prove it. This is just practice on proofs. That's all it is. Okay, so what I'm going to do is I'm going to talk about angle 1. I want to show that angle 1 is congruent to angle 5. I want to show that angle 1 is congruent to angle 5. What do I know about angle 1 right now? Look at your picture. What can we say about angle 1? Lynn, what do you think? It's vertical to angle 4, so what does that mean about angle 1? It's congruent to angle 4. So I'm going to say that angle 1 is congruent to angle 4 because the vertical angles congruence theorem. Vertical angles are congruent. That's the theorem. Again, we're trying to show that angle 1 is congruent to angle 5. So now when I know that 1 and 4 are congruent, I'm going to mark number 1 with that same congruent mark. I'm trying to show that angle 1 is congruent to angle 5. Can I show that now? Why? They're both congruent to angle 4. So what, or I'm not going to write down they're both congruent to angle 4. I'm going to write down a property that means that. Okay, so I'm going to say angle 1 is congruent to angle 5. And looking here, I've got 4 is congruent to 5, 1 is congruent to 4, so 1 has to be congruent to 5. Aaron, do you know what it is? Yes, the transitive property. Hey, Lynn. I can't go that far. Okay, so now if I have 1 and 5 both marked congruent, I can say that these lines are parallel. I can go and say that these lines are parallel. I'm not using the alternate interior angles converse. What am I using? I kind of already gave you a hint earlier. If I'm talking about 1 and 5, somebody volunteer. Who wants some candy? Cameron. Right, we're going to use the corresponding angles converse. Good. So I gave you a bunch of lines here because I didn't know how many we needed, and I just cut and pasted a blank thing, so we might not use all of them. Oh, I was so close. Man, I was strong on that one. See how hard I threw that? Good. Okay. I know you were all thinking that. All right, in this diagram, R is parallel to S, and angle 1 is congruent to angle 3. We have to prove that P is congruent to Q. So I want you to start. What can you come up with? Write it down. Make sure we have numbers in front of all our steps and reasons. I will take off if you don't do it the proper way. Looks like everybody knows what's going on. To start, we've got step 1, R parallel to S, and angle 1 is congruent to angle 3. I'm going to go over and mark angle 1 and 3 congruent. And the reason is given. So then we got to kind of plan what we're doing here. Our ultimate goal is to prove that P and Q are parallel. In order to prove that P and Q are parallel, we have to show that the transversal that cuts through P and Q, which could be this one or it could be this one, we have to show that the transversal, I'm going to use this one. Anybody know why I'm using this one? I'll even highlight it. Does anybody know why I want to use this one and not the other one? Because they put a 2 there. Yeah, that's why I'm going to use that one. I need to show that these two lines are parallel, so I need to use this transversal and somehow show that angle 1, or what is that, a 3? Angle 3 is congruent to angle 2. If angle 3 is congruent to angle 2, then I can say the lines are parallel. All I know right now is that angle 1 is congruent to angle 3, and I know that the blue and not colored line are parallel. So if I ignore this for a moment, and I look at my pink one being a transversal, I'm looking at the pink one being a transversal that cuts through the blue line and the not colored line, that cuts through R and S. My line Q cuts through R and S. Is there anything that I can come up with? John. What could I come up with over on this side? Right, and then you said the correct reason. Angle 1 is congruent to angle 2 because why? That would not be the converse. I can't write and talk at the same time, so I'll tell you in a second. Corresponding angles theorem. That wouldn't be the converse because the converse says that lines are parallel. The actual theorem in the first place says that angles are congruent. So since I'm saying angles congruent, that's the regular theorem. The converse says lines are parallel. So now I know that these two angles are congruent because they're corresponding angles. And like I said, I was ignoring line P, and I was just looking at this being two lines with a transversal, pink transversal cutting through. So again, we are trying to show that 3 and 2, 3 and 2 are congruent, which they're marked. John. Oh, that was not. I'm sorry. Kind of like rolled off my hand there. Sorry about that. Good thing you're awake. All right, we're trying to show that 2 and 3 are congruent, which I've already marked it, so I should be able to say it now. However, I need a reason why I'm allowed to say that. You're not going to say, well, I marked it on the diagram. Matthew? Okay, so I can't say that yet because I don't know if P and Q are parallel. That's what I'm trying to prove. So there's a different reason why I can say those are congruent. So not yet. I can't go off of the parallel lines. Avneet? It is transitive because we marked 1 and 3 congruent, then we marked 1 and 2 congruent. So that means 3 and 2 have the same marking. That's transitive. Oh, sorry, Matthew. Thank you for trying. Right.
Would it also be substitution?
I see how substitution would be the same in this case. So yeah, I would take either. Okay, so now if I know that these alternate interior angles are congruent, can I now say the lines are parallel? Why? Let's see if anybody who hasn't had candy would like to give me an answer. Maggie?
Is it
alternate interior angles, converse, because we're showing the lines are parallel, so we're going kind of backwards. Right. Alternate interior angles, converse. Very good. All right, you're kind of far. I don't have very good aim. I'm going to like stand up and come a little closer. Everybody in the vicinity, pay attention. Oh, I don't throw things, so. Oh, yeah. All right. Let's pause on our brain. So for example 2, you guys have to prove that R is parallel to S. Right now, you only know that P is parallel to Q. So any sort of corresponding alternate interior, alternate exterior, or what's the other one? Same side interior, any of those that you're going to use, you can use with P and Q. What you'll have to do is you'll have to use one of the converse theorems with R and S. You'll have to use a converse theorem. You'll have to find 2 angles that are either supplementary or congruent on R and S before you can say that R and S are parallel. So you're going to use the regular theorems to find congruent angles or supplementary angles, and then you're going to use the converse theorems to show that these are parallel. And they've labeled 1, 2, and 3 to guide you. It's not like a blank canvas here. They're saying, you know, they told you something about 1 and 2, but there's a reason why they put 3 in there. So keep going off it. I'll give you another couple minutes, and then we'll go over the answer, and then I'll come around and answer your questions too. So no problems. We wrote step 1. P is parallel to Q, and you said angle 1 and angle 2 are supplementary. Right? Okay, given. And then step 2, some people did one thing, some people did another thing. I think that step 1 and 2, what I'm about to do, could be in either order. When I write step 2 up here, that could have been your step 3. I said step 1 and 2. I meant 2 and 3. Your step 2 and 3 could be in either order. So if I write one of them first, that doesn't mean that one had to be written first. It could be either order. So a lot of you said measure of angle 1 plus measure of angle 2 equals 180 degrees by what? Definition of supplementary angles. Just make sure that when you do write this, you're putting M in front of the angles because that says the measure. If you just put angle, then we're just talking about the picture. I'm not talking about the number. And then 180 has a degree symbol. Pet peeve of mine, put it in there. Thanks. Okay. It's just I teach higher level math, and if you aren't putting it in now, when you get to higher level math, you're going to make a lot of mistakes. That's why I'm trying to be picky now, because I teach the next 2 courses above geometry. So I see you guys could have me 3 years in a row. Lucky you.
Oh, yeah.
Aaron's brother had me 3 years in a row. Okay. He's not in a mental hospital yet. He survived. He survived. Okay. Next, or it could have been first, 2 or 3. Some of you said angle 2 is congruent to angle 3. What?
What?
Huh? How? Alternate interior. So let's look at that. Look at alternate interior right here. We know that these two lines are parallel. We know those 2 lines are parallel. It's given. We also know that this is a transversal that cuts through 2 parallels, meaning angles 2 and 3 are alternate interior. They have to be congruent. So that's by alternate interior angles theorem. So that's showing that angles are congruent. So now a lot of you got even further, but you missed one tiny little thing. A lot of you now try to put in angle 3 right here and take out angle 2 by substitution, but I can't do that yet. Because right now this is an angle 2 congruent to angle 3. Up here this is a measurement of angle 2. So in order to switch them out, I need to go to step 4 and say that the measurement of angle 2 equals the measurement of angle 3. What tells me I can take congruence and change it into equal? Who is that? Who's talking over there? Okay. What is it? Yeah, definition of congruent angles. Rukai, what you want? Nerds? Nerdy nerd? Okay. All right, and then once I know that the angles are congruent, now I can take out angle 2 from this statement and I can put in angle 3 instead. So at this point, I can say measure of angle 1 plus measure of angle 3 equals 180 degrees. What allows me to take out angle 2 and put in the measurement of angle 3?
Substitution.
Oh, everybody answered that one, okay? Substitution. So now, back in my picture, if I know that angle 3 and angle 1 are supplementary, I'm going to turn my picture so that it looks like what we've been seeing, and I'm going to ignore this line. If I know that angle 1 and 3 are supplementary, they are on the inside of 2 perhaps parallel lines with a transversal same side of the transversal. So right now they are what kind of angles? Lynn, what kind of angles are they? I didn't know there were so many Lynn's in here. Just kidding. Consecutive interior. So if our consecutive interior angles are supplementary, which I just said they are supplementary, then we can prove that R is parallel to S by the consecutive interior angles converse. The converse is what proves the line's parallel. So you guys did a really good job working in groups. You got most of that. Again, when we do these on a quiz or test, and when you do them on air, it's not going to be a blank one, because it's too hard for me to grade. It's too hard for the state of Ohio to grade all those for the air. They're not going to give you a blank one. They're going to give you pieces, and you have to fill in the missing pieces. It'll probably be like a drag and drop thing, would be my guess. Okay, we have one last thing. There's one thing to add to your vocab packet later. It's called transitive property of parallel lines. It says if two lines are parallel to the same line, then they are parallel to each other. So in the diagram below, P is parallel to Q and Q is parallel to R. So I'm going to say that P is parallel to Q by marking it in my diagram. And then I'm going to say that Q is parallel to R. So the same marking that I put on Q, I should probably also put on R, because they're parallel to each other. So if they all have the same marking, I can say that P and R are also parallel, right? P is parallel to R. That's by the transitive property of parallel lines. Transitive property of, that looks weird, but I was trying to draw parallel lines. We are trying to find the measure of angle 8. How can we get there? You can probably tell me, but how can we get there? How can we like go the steps like a proof? We don't have to do a proof, but how could we get there like we're doing a proof? 115, I need to find 8. Any ideas? You guys have had candy. Let me give everybody an opportunity to say it if they want to, and if not, then I'll just give more candy to you all. John, you only have 2 pieces so far, right? Stephen, you have any ideas?
65.
Well, that's the answer. How can I get there? You're totally right. It is 65. But how can I get there? Alternate exterior would tell me 115. That would take me all the way down here and put 115, right? That's alternate exterior. So this angle here by alternate exterior angles. So then how could I get to angle 8? How do I know they're supplementary? So it's a line, and there's 2 of them. They make a line. Somebody else help him. What am I talking about here? Denise, do you know what I'm talking about? These 2 angles together? He said they're supplementary. They make a line. Alex, what do you think? They are a linear pair, which the definition of linear pair says they're supplementary. So we're going to say that measure of angle 8 equals 65 degrees because the linear pair postulate. Okay? I'm going to go ahead and hand your candy out in a second, but we have a worksheet to practice on this stuff. It's a short-ish worksheet. And then after the worksheet, we're going to pause and kind of come back together again. You might not be able to finish the worksheet in that whole time, but we're going to do 2.5 new constructions today. So I'll let you work in your groups on the worksheet for 10, 15 minutes, and then we're going to do constructions, which you can't do outside of my class. So